Login acceptance.
All right, welcome. Woo. Great to see people here on stage. Wow, thank you, yeah. It's great to be back on stage. I can tell you, these 1.5 years of just staring at your camera giving talks, it's just like totally not fine. But let me just see if that works with the lights. I need to take a picture for my DevRel colleagues at MongoDB, so they believe me that this actually happens again. Everyone just waving. Woo! Great. All right. You will see the result on Twitter later. So, yeah, thank you for coming, and thanks also to the organizers for putting this together. Totally excited to be back on stage. My name is Sven. I work for MongoDB, and this talk is about the effective developer, right? So, who wants to work harder? 1, all right, 2, great. You can go out and work harder, no problem with that. Don't waste your time with this talk. Who wants to work smarter? Yeah, most of you, right? Yeah. But don't be fooled. Don't be fooled with this talk. It is not, easy to work smarter. You also have to work hard to be smart. Wow, that was a rhyme that I just came up with. How cool is that? So, and this talk is a little bit about my experience leading a couple of software teams, and also talking to other software teams, how they can be more outcome-oriented instead of working on output. But I will tell you all of the story in a sec. So, when we think of effective developers, what do we think? So here's a list of things that I think effective developers are actually doing. They write very smart code. What you normally write in 10 lines of code, they can just condense to 2 lines of code. Super smart, super cool, very, very smart developers, these effective developers. Just saving a lot of lines of code. What they also do is they fix bugs immediately. So if they actually feel very proud of their software, and if they see a bug or if a bug gets reported, they just jump on it immediately and fix that because they feel embarrassed about having bugs in the software. So they just fix it immediately, put it in production, bug fix, everyone is happy again. And then also these developers are adding features like a champ. Right? So imagine you stay at the morning on the daily scrum or daily stand-up at your scrum board, and so you're just saying, who's doing this task here? And then the effective developer says, oh, well, yesterday evening, I just coded it, and also put in the pull request, so do you just have to review it, and then we can just put it in production. It's already done. Just adding features like a champ. And if you have a feature request, you just go to this effective developers and they will just make it happen. Also, they never stop. They always hacking. So you see them always with hands on keyboard. Code is spreading out of their fingers, and they just hacking all the time, right? They never stop. They always just hacking. And also, they live and breathe code. You can wake them up in the middle of the night, right? And then just say, hey, we need to change this button, needs to make a connection to the database, and then come back and fill out the form here. How do we do that? And this effective developer that just tells you, well, go to that class and that method, you change this line of code, and then make a connection to the database, make that happen, and fill out the form. They know the code inside out. Great. Super, super effective. Actually, I was feeling like this. Back in 2003, I got 3 years, so I graduated 2000, and then I got 3 years in my job. We started with a greenfield project, and I was just feeling like this. Super, super effective. I know the code base inside out. I was fixing bugs. I knew where to look for. Great, super effective. Now, looking back almost 20 years later, I was just like thinking, really? Was I really super effective? Well, let's find out. So, as I said, I was writing very, very smart code, right? Super, super smart code that I looked at again 2 weeks later and said, oh, it's so smart. And I knew it was super smart when I was writing it, but please don't touch it because I don't know how it actually works anymore. So don't touch that code. I was fixing all the bugs, right? I was just like super embarrassed if someone found a bug in the system and reported a bug. So I was just like stopping everything, fixing the bug. But I should actually taking more time to really think about it and look at the root problem. I was fixing bugs always, right? Maybe 10 bugs a day or something. Well, just like should have taken more time because I just wanted to have everyone just like running software. But if I would have taken more time and think about the root problem, it would have saved me probably weeks later on. So wasn't very, very effective on that end. Adding features like a champ, right? I was just adding features. Someone actually came into my office, tapped me on the shoulder and said, yeah, we just have been to this customer and they wanted to have this feature. And I was just like, oh, no problem. I know how to do that. And then this feature got never used, right? And we have all been there, adding features, spending weeks on things. But then someone said, oh, you know what, it's not what the customer wanted or not exactly what the customer wanted. So those features got I wouldn't say never used, but very rarely used or just used by a fraction of our user base. So that is that story. Also, I never stopped. I was always hacking, and I felt like I'm super productive if I'm always hands on keyboard. Just if someone came and or if I had to stop and say, okay, I need design to take a look at that, and then I was just grabbing the next task and work on the next task. That actually required a lot of context switching. So I was actually constantly switching between some things. I was running here and then stopping, and we all know that context switching that takes time, right? So we have to just like be in the zone. If we are in the zone, it takes us approximately 15 minutes, 20 minutes to go into that zone and be in that zone. So always context switching takes time. So it would have been smarter if I would have just looked at the task and see like, okay, yeah, well, a designer should take a look at it before I actually start the whole thing and then stop in the middle of it and come back later. I was live and breathe code. I knew the code base inside out. I wrote most of it, so I knew everything. But then also at the same time, I was very concentrated on the code, where I actually should have taken more time to just like get a little bit of a broader view of this whole software. Where is this software going? I was adding features, I was doing everything, but where is this whole software going? And in which direction do we want to push it? So I was just like too much in code where I should have get more the broader view of the whole software project. Said all that, all the things here on the right-hand side is about efficiency. So I was very efficient. I was just like, if you look at how many bugs I fixed, how many features I implemented, I was super, super efficient. How many lines of code I wrote, great. But where I should have worked actually more here on the left-hand side, right? On effectiveness. Was I effective? Not really, I think. And if I pushed myself more, I could have pushed here, work on the efficiency side, but that would have required me to work harder, where I actually should have worked smarter. Okay, so you got this. This is actually the talk, work smarter, not harder. And I have a couple of things here, and it's probably not a complete picture of how you become effective, but it's some things that you should look at on your daily basis and just see where you can actually work a little bit smarter. And the first thing I want to talk about is how we code as a team, right? It's not just our individual code. We need to write code as a team. And how can we be smarter by writing code as a team when we think about it? So writing good code, and we know that, everyone knows that, writing good code takes time. So sometimes I was sitting like this, and my code was just like I was looking at the code, and then my boss came and said, "Hey, Sven, what are you doing, right? Why are you thinking so much about the code? It is working, tests are running, great. So what holds you back, right? Just I said, I want to improve the code. I want to make it look better. And then my boss said, well, the machine doesn't care. The machine doesn't care. It's working. Come on, move on. But then I said something like, machine doesn't care. Yeah, sure. Yeah, we compile it to machine code. It's got executed by the CPU, blah, blah, blah. But actually, humans do, right? Humans care about well-written code. Why is that important? It is important because we read code more often than we actually write code. So we maybe take a couple of minutes to write that code, but then our colleagues are just like, or me, myself, looking at that code again and just like trying to understand what it's doing. So we should spend more time on making the code more readable. And if you look at this piece of code here, it doesn't look very, very good. There are a lot of flaws in that code. And I just like look at it and say, I don't get what it's doing. Then I put in git blame and just like want to find out like who has written this piece of code, and then I found out, oh, it was actually me on a Friday afternoon, right? I want to put it into production, I want to get it done, and I knew I wanted to fix it on Monday morning, but Monday morning there was another problem, of course, where I jumped on. We have all been there, and then we look at that code and we feel embarrassed about that. But there are a couple of fixable things in there. If you look at some flaws here, public, private, protected, whatever, then the whole method names is like awful. The indent is horrible. Sometimes like this, sometimes like that. We have the curly braces on the same line, on the other line. All of this makes the code hard to read. Or here, like the magic number before the variable, or the other way around, or the variable names. Well, yeah, it's horrible code. It's hard to read because it's horrible. There are a lot of tools that helps us actually automating that. Our IDEs can do that. But as a team, we need a common formatting of our code. So the whole team needs to agree on a common format. And I don't care about. We can later have a discussion about tab versus spaces or whatever. But the team should have the same formatting of the code. And as I said, some things are fixable by tools. When you check it in, it's done automatically, or your IDE takes care of that. But making code more readable helps me actually to just grasp what the code is doing. It's not just the variable names; it's also the formatting. So my eye actually knows where I have to look for the variables and where to find the methods and so on, and how everything is formatted. It's a little bit like this. The human mind does not read every letter by itself, but the word as a whole. When I open a file, right, I just like get what this class is doing. Or where to look at, where to find things in that class. So very important that we actually, as a team, agree on common standards, on formatting standards. I was saying I was writing clever code, right? So smart code, I called it before, like super clever. I felt clever when I wrote it. I didn't feel clever a week later when I looked at it because I didn't understand it anymore. But why did I do it? Because I could. I was just like super fascinating that I can write that. It was a little bit maybe also to show off a little bit, right? But we shouldn't just write so clever code. We should write simple code. Code that is simple to understand for actually our coworkers, right? It's not just us that probably have problems understanding that code in 1-2 weeks. It is important that the code is simple enough for everyone in the team, because we write code as a team. Someone wants to maybe change something in that class or in that method, so they just like look for things, and if it's too clever, it's hard to find out, and it takes a lot of time. So that we can save a lot of time by writing simple code. Now, the question is like, what is simple code? How can we find out if our code is simple enough, right? I've one advice here. Make a canary test. You know, canary birds, when we were back in the comp, when we were taking the canary bird in the coal mine, air gets polluted, everyone has to get out because the canary bird just died, fell down. We can do the same thing with our code and just like make a canary test with our code. Show your code that you just have written to your junior developers, right? If they say, well, I don't understand everything, but I get what the code is doing. Your code is probably simple enough, right? So that everyone in the team understands it. So now, how do we get that into a process that we all can follow? Yes, we're doing code reviews, right? Invest time in code reviews. So we actually make a pull request so everyone can look at it. No doubt. But code reviews are actually, of course, to inspire our junior devs and to have a consistent code quality, but code reviews are also pretty hard, right? People have worked with so many teams, and there's always resistant to just like show my code to other developers or show their code to other developers. How can we make code reviews more pleasant? And you probably have all also have this one developer in the team that says, I don't like code reviews. So how can we make actually these code reviews a little bit more pleasant and a little bit more humanized code reviews, right? So here are some tips that we have put together as a team when working with code reviews or working with pull requests. First, as a reviewer, try to understand why this person has written this code. If you don't agree and say, maybe that's not what I have been written, but try to put yourself in the shoes of that developer and just like try to understand. Maybe there was no other way to do it. It's easy just like to say, no, that's not the best way to do it, but try to, first thing is try to understand that developer. The second thing is just like, if you still think this is not all right, criticize the idea and never the people. If you criticize people, your whole code review process falls into pieces because people don't like to have code reviews anymore, and you have resistance against code reviews. So try to criticize the idea and never the person. That's super important. Also, don't rant. Never rant. Just like be pleasant, be nice in your comments when you make comments, and try to make suggestions. Try to say, okay, please change this to, or you could change this to that, but also don't try to spoon feed. Don't come across as the expert that knows everything, right? Just like give hints where people can also learn, because we're learning from those things. We're learning from code reviews, and you never learn if you just like copy paste the code that another person has just put into your code if you correct it that way. Also, comment on positive things too, right? That's we always forget. If we see something that is cool, why don't we comment on it? That also helps just like have a positive attitude for code reviews, and it's great if you hear some colleagues saying, oh wow, this is a great solution, great work, good work. We all want to hear that. So don't forget also to comment on positive things too. So these are just like a few suggestions. Put them in your wiki, or if you're working in an office again, put them on a wall or something. Don't just copy those. Come up with your own to make code reviews more pleasant if that is a problem actually within your team. Especially also if you onboard new team members, they feel just like more embraced because it's a new code base for them. They just like have also that feeling, oh no, I'm just like putting in code from other people's work, and then get this positive attitude around code reviews. With code reviews, we also learn about how other people write code. And learning is super important to be effective, right? So just time travel back with me when I was a young developer, as I said, over 20 years ago, having my first job, coming fresh from university, learned a lot of things, and then jumped in my first job, and I looked at the code base and just was super amazed about the whole things that is possible with code. Amazing, great. wow, I was really pumped, and I learned things every day, something new every day, and I was super motivated. And then, yeah, we are moving on in the technology. So also, you learn a lot of new stuff here at Devoxx Poland, and you learn a lot of stuff like from reading from blog posts and all these things. And we, as an industry, are always super excited about new technology that will save our lives or save our developer lives, and we can save, I don't know, 2 lines of code by using that new technology. We get super excited about it, right? Yes, but also, after a while, when you're longer in this job, right, you have seen a lot of stuff. You have seen a lot of new technologies. And you're probably not that excited anymore about something new coming up here. You may say, like, I will also survive the microservice and serverless hype. That will move on. I've seen that coming, going, blah, blah, blah. Oh, really, a new front-end framework again? Can we not just stick to something? Angular is great, so let's use that. Scrum boards, not for me. I know what's important, don't tell me, right? Or code reviews. My code is great. My code is perfect. No one has to review it. It's great. So you become a little bit this grumpy developer, right? That's sitting in the corner. You don't want to do that, right? But there's a small grumpiness in all of us because we have seen things come and go, and then you have to refactor everything out again, these new technologies, and bring the new I've been there. Okay. If you talk to these grumpy developers, they always say, well, I'm here since years. I know how to develop software. Now. I know it now, right? But ask this question to these grumpy developers. What do you think? Is software development changing? Is that changing? And we have a clear answer for this. Yes. Yes, it will be changing. We are not writing the same code as 20 years ago. It will always change. So we need to continuously learn. It's not a solution to become grumpy, sit in the corner, and just rant for the rest of your career. So continuously learn. So how can you continuously learn? Back in the days when I was commuting to work, before the pandemic, I was actually using that time to listen to some audiobooks and podcasts. So I was using that time trying to learn something new, trying to hear other opinions. So I was using that time. Now, I'm working from home now since 1.5 years, and I'm not commuting anymore. But what I'm doing, I'm also not moving a lot anymore, so I had to start working out. So now I'm doing that during workout. But find your time to just try to learn something, and podcasts and audiobooks is a perfect, for me, it's a perfect way to just keep up with what's going on. Meetups are a great way to learn and to connect. Also, meetups are probably, I don't know how it's in Poland, in Germany, where I come from, it's not happening that much at the moment in person. But in the last 1.5 years, I've met so many great people online. It's just amazing. But once we can meet again in meetups and have these meetups again, then go to that. It's great for connection building and also to learn something new stuff. What we do at MongoDB is, or in the developer relation team, is that we have this book club. And this book club is I'm not a book reader. I told you, audiobooks, podcasts, that's more me. I don't like to read that much, but we are reading a book all together as a team, a chapter each week, and then we meet once a week and discuss this chapter. So we have a conversation around it, so also I hear other opinions about it, and it's really great, and I learn so much from that, and it forces me also to read books again. When I was a team leader of a software development team, we were doing video Fridays because not everyone is actually like me that wants to learn and is keen to just jump on new things. Other people in the team had other priorities, but we wanted to bring the team together to learn. So we were having this Friday afternoon, stop working, watching a video, maybe from Devoxx Poland. There are so many great videos out there about technology. And afterwards, we were discussing it. And it helps the whole team just to have a smooth start into the weekend, but also to just as a team, learn and do something together. Now, I hear that sometimes from junior developers. why should I learn, right? Why should I really learn and do all this stuff? All the answers are already on Stack Overflow, so I just don't have to learn it. I just copy-paste it, done. Well, maybe I'm that old dude, but I'm always in the vein of like trying and solve the problem myself. I want to try and learn why it's failing, why it's doing. It's not copy-paste. I don't learn anything. So first, try and solve the problem yourself. If that doesn't help, sometimes it helps actually just to step away from the desk and think about it a little bit from another perspective. But if that doesn't help, like ask for help. But before you go to your coworkers or start a Zoom call, just like ask yourself for help. There's this technique called rubber ducking. So there's this rubber duck, and you tell the problem to the rubber duck. And it's just like you just like go on another level and try to explain it to a rubber duck, and the rubber duck is always smiling to you. And all of a sudden, new ideas come to your mind. It's just amazing. But if you're in an office, maybe that's not the best thing. If you're talking to rubber ducks, maybe people think you're a little bit crazy or whatever. Then just like go to someone and ask for help and admit that you don't know. This is actually the way to solve problems, just like how we learn. We try to solve the problems ourselves. And it makes new connections in the brain that we can use later on for our next challenges. But it's not just about making new connections. Also admit that some things that you learned in the past are not true anymore, right? Get rid of some connections and learn to unlearn. When I was in university, I learned that waterfall is the only method that how you can develop software. Until I did it, and I thought this is a stupid thing, and then agile came along and we threw away our waterfall processes. But you need also to just like admit, otherwise we become this grumpy developer, right? And you don't want to become this grumpy developer. But let's admit that some things are not true anymore that you learned in the past. You also have to learn to unlearn that some new technology is coming and waving away old technology. So this is actually a continuous thing, right? It's learning, unlearning, but there's one important ingredient missing. Like we cannot just learn from books, learn from problem solving. We also have to try things out ourselves and get our hands dirty. We also have to experiment. And if you want to become effective, this is a tool that you should have, right? To experiment, to be more effective. Now, when is the time to experiment? Well, we don't need to experiment because the product manager is telling us that everything that we should work on is actually on the board. Well, not everything fits on the board, so we know the rest is somewhere in Jira. So there's everything is actually in Jira. So we know that everything is there. So no doubt, why should we experiment, right? This is what we should work on. This is what the customer wants. Great. But how do we know that this is the best idea that is on the board, right? This might not be the best idea. Actually, we know not everything that is on the board and comes from our product managers or whoever puts the post-its on the board is the best idea, right? What about new technologies? Maybe new technology can help us, right? So we have known unknowns. There are known unknowns. We know that this can't be always the best thing that we should build for the customer. Maybe there's a better solution out there. Maybe we need to just look for a better solution. Maybe actually there's a new technology that can help us and we're trying to reinvent the wheel here. Or actually that we're missing an important opportunity. We just like work on the wrong side of the software where we should invest more time on something else that brings our users better forward, right? So don't be shy, just try it out. So how can we know about the new technologies? Well, we can just learn it by trying it out and experience it ourselves. So also what we do is we're taking actually 1.5 hours each week off to just code and try some new technologies out there. Maybe if you haven't worked with Kubernetes, just like try that and work a little bit 1.5 hours as a team, right? Come together as a team and work on Kubernetes, or if you want to learn more about TypeScript or whatever, just use that time, 1.5 hours a week, to just learn. It's nothing that you should use in production immediately or use in your working software immediately. You can just like try something out and use that time to learn as a team what you normally do on weekends or whatever. Just like bring the whole team together and learn. That means 1.5 hours of trying to do something is 1.5 hours of improving. Then also look at the whole tool chain that you got. You have probably used, I don't know, 10, 15 tools to build your software, to run your software. So look at the whole tool chain. Are you using these tools effectively? Do you know that? Do you know the latest development of these tools? Also take some time off and maybe use half an hour each week, and each of your team members try something out, read through the release notes and see if we can figure out something. Or try to learn some new tools that are out there. Maybe Jenkins isn't the best solution anymore for your software. Maybe you should try GitHub Actions, or maybe you want to use IDEs in the cloud with pre-built development environments like what Gitpod does, so you don't have to build it locally. It's all built in the cloud for you. Try that out. Maybe this is not a good solution for you. Maybe this is a great solution for you, but you don't know if you don't try it out yourself. So try things out and just invest half an hour each week, and then maybe divide it into groups in your team or divide individuals. But what companies really want, right, when you experiment, is this here: innovation. Everyone wants innovation. We need to be just the most innovative. We need to have the most innovative product. Otherwise, our competitors come and take us over. So bring us some innovation. The problem is not that we don't have the good ideas, right? The problem is not the lack of ideas. The problem is really the lack of time to try them out. We never have time. We're working always on the Scrum board. We are always moving just like cards over and work on that. We never take the time to just like step back and try some great ideas that we have out. How much time would you need, right? Let's say you need 40 hours. This is actually what we do at MongoDB. Every half year we take a week off and do some skunk works, what we call skunk works projects. That's what we do. Maybe you need 30 hours. Maybe you need just 24 hours and run a hackathon. Who's running these 24-hour hackathons here in their company? No one. All right. One. Great. Good job. So my previous job, I worked for a company called Atlassian, and actually we were on the forefront of this 24-hour hackathons, because we were just like most the inventor. We didn't call them 24-hour hackathon. Actually, we called them FedEx days back in the days, until actually FedEx came to us, because they became very, very popular. And said, can you please rename this FedEx days? Because if you Google FedEx, your FedEx days comes up first in the results. So we renamed them to Ship It days. Same concept, ship something in 24 hours. That was the concept. And at Atlassian, we ran them quarterly. And we divided this in 3 phases: the before planning phase, and then the during the event phase, and after. So in the planning phase, what is super important if you do that is plan ahead of time. Plan 2-3 months ahead of time and announce this day will be our whatever, hackathon day, whatever you call that, FedEx days, Ship It days, whatever. So these are just like, so everyone can plan their releases around that, they can plan their meetings around that, so you know it's in the calendar, so you can start planning for hackathon. Then also announce and tell stories. What do I mean by that? It is like, don't just go in and say, what should we do, and spend the first 4 hours finding out what good ideas you should work on. Try to write them down, find some people. We were running brown bags, actually, to just like find a whole team. Some people didn't have the time to just think about a good idea, or they didn't come up with a great idea for that hackathon. So they joined this brown bags and then found a team that they could join and run their hackathons. Then during the event, Of course, time is ticking, 24 hours are ticking down. There was a big watch hanging over our heads, showing us that we just have 24 hours to deliver something. Having fun is super important. You're working on your own creative ideas. It is super important that you also have fun. It is actually fun to work on your own idea. And then also don't forget to get energized and eat and drink. Some people went home during the night. Some people slept under the desk. Whatever is convenient for you. It doesn't. We couldn't see really if that impacts later the winner, if they have spent the whole 24 hours working on something, or if they just like have spent 8 hours on working on something. Doesn't matter. At the end, Friday, 3 p.m. we meet again, and then we showing our innovative ideas to the whole company. Got 3 minutes to pitch it, to show it, and then we vote for the winners. And all those great ideas just got exposure to the leadership team. They saw that and said, "Wow, cool, great idea. Good job, Sven. Let's consider putting that into the product." And then you can get it on the product roadmap. Maybe your product manager just says, "Oh, great, let's put it on the product roadmap." Sometimes it does. Sometimes it wasn't on the product roadmap. But then also just like go in and plan already for the next hackathon. Super important. Also, not just our engineering teams were running those. They were a little bit like our sales team and legal teams and marketing teams were a little bit jealous. They also wanted to do something. So we expanded this to you can do whatever you want in the 24 hours if it helps the company or the product to move forward. So they came actually up. One team came actually up with building a collaboration space. That's a hidden whiskey bar within the Sydney office. There should be a video. Yes, right. So if you open this, if you want in the Sydney office of Atlassian, just go in there. There's this hidden whiskey bar. It's a collaboration space that they've built in 24 hours. I know it looks a little bit scary. There's so many people in a small room without masks, but hey, that's what they built. So also contribute to this 24-hour experimentation time. So 24-hour hackathons, run them every quarter, is 0.7 hours a week that you spend on innovation. Well, you should get that time, right? That's a good argument to just like say, hey, if you want innovation, this is the way to go to show it, show innovative ideas and get the innovation from the whole company and not just from the innovation team or whatever you have. All right, so now also you have these great ideas and maybe people don't take that and say, we need to implement that in the product, but you are convinced that this is a great idea. So we have no knowns, right? We know this is a great idea and we want that in the product. So these great ideas. When do we have time to work on that? And also, what we also had or have is these small little things. I call them paper cuts. So these are just like small bugs. For example, if you just you need to click 2 times, the one time of a button, then on a form, which you could just normally do in 1 click. But you never get time to just change that because there's a ticket somewhere in Jira, but it's not prioritized very high, but you really want that, and it hurts the customer. And there's this term of death by 1,000 paper cuts. If your software is full of these paper cuts, it will feel buggy, right? And you should spend time also working on these small things, these paper cuts. So what we actually did, and this is a little bit like hackathons on steroids, working on all those things in so-called innovation weeks. So every 8 weeks, that was the cadence of the team, they actually took 1 week off and work on the innovative stuff. And the good thing is, it's a little bit like the 20% time from Google, even though this is not 20%, but anyway, it's a little bit like that. But we tried the 20% time, and we always had the feeling like we're letting our team down, or we're not working hard enough on the sprint by using our 20% time. So we were actually taking this time off as a team. And this helped us to just get those innovative ideas into the product and also work on some paper cuts. All right, this is of course a bigger investment. This is 5 hours if you go down that, but has 7.7 hours a week on improving. Not too bad. Invest time in discovery time. Invest in discovery time. That's just what I want to say. It's not. Sometimes it doesn't work off immediately, But I can tell you that we had a project at Atlassian that went now to $1 billion product, and that was a hackathon project. All right, work on what matters to be more effective. So you should know what really matters. So I found this video here. Great, you can control the car radio by gestures. There's a camera behind, and then you can control the car radio by doing this gestures. Great, right? I don't know why they built it. I don't know what the problem was they wanted to solve. I think they just wanted to show that it's possible and build it into a car. I'm not sure this is the right thing to do. I don't know what touchscreens can do, what this is, or what this can do, what touchscreens can't do. I don't understand it. And we are so fast in just like talking about the solution without asking what is really the problem. Sometimes we get, okay, we need this thing in the software, this here, right? So build it. And we say, okay, yeah, we build it, of course, yeah, it must be in there. But do we really think deeply about what is the problem that we want to solve? And how do we know that we actually solve that problem at the end? Where's the validation data, right? So ask yourself these questions. And also, what are possible solutions, right? They are probably not just the first solution that comes to mind is the best solution. Just talk about it. Take some time to think about, really, what is the problem we want to solve for the customer? And we have actually worked hard on it and came up with this, what we call a project poster. So every time we want to work on something, we need to fill out that project poster. And that is actually asking the right questions. So this is a development of 2-3 years to getting to the right questions. And that is, of course, not a poster. It's a wiki page that asks these questions and that you have to fill out. And it's not only about filling it out and then getting the whole team aligned on what we want to build and what the problem is. It is also great to just like, when people ask, what are you doing and why are you doing it? You can just like give them the project poster or the link to it, and then they can read through it, and everything is documented on that. And that's, of course, a living document because things change. Okay, now we have filled out the project poster. What's the next step? We break everything down in user stories. So let's have that here. As a user, I want a new statistic button so that I can see the data sets, the number of data sets, right? Yeah, it's a valid user story, right? Except this is not a great user story. It just talks about what we want to build. Instead of this, a user story should be formalized like, as just mean. I want to know the number of data sets so that I can plan for growth, right? So I want to know how many data is in my database so I can plan. That could be a valid user story for MongoDB, for example. And you see that we're not just saying also, so we were talking about the problem here that we want to solve, so everyone gets in, okay, we know what problem we want to solve then, but we're also talking not just like as a user. That's so abstract. We say as Jasmine, right? Because Jasmine is a great user of MongoDB. She's a developer in training, and then we have Lucas, who's a full stack developer. But now that we plan everything for Jasmine, we also have to think about like, how will that work for Lucas? Is that also good for Lucas? Lucas is a full stack developer, probably a little bit more experienced than Jasmine. So how would that work? Of course, these are not really users, these are personas, but we take our personas to every discussion that we have. We always think like our users. So what would our users think? Think more like your users. And you probably also have personas, but if you don't, just write everything down about a specific persona that you have that uses your software. And you can't really escape from our personas. They are everywhere. We take them, as I said, to meetings with us, and you can't really escape. Even when you go to the bathroom, they're hanging out there. But now let's say you have written your great project poster, but you have plenty of those, right? You have plenty of ideas and plenty of problems to solve. There's never a lack of problem. What should you work on first? I always say, like, look at your happy path, right? Where 80% of your users spend most of the time. This is what brings you the most impact in your software. So work on that. So we're doing a technique called journey mapping. You probably have heard about it. So you write down the journey of the user, then you identify the problems, and then you just like come up with possible solutions. And you're not just doing it So this is a happy path the user goes through, and you're not just doing it for one persona. Of course, you're doing it for all the personas because every journey is different from your users. Now, you might say, Sven, we are developers. This is all product manager things, right? Or product owner things, right? We write code. The product managers should care about the product. We just put the ideas into code. Why should we think about all these things? Right. I wish engineers spend less time understanding the problem and more time coding. Who said that? Who said that? Sorry? I said nobody ever, right? Nobody said spend less time thinking about the problem, understanding the problem. It is essential for us. Maybe if you're a junior developer, and Jessica was touching on that yesterday too in her keynote. Maybe if you're a junior developer, yes, try to understand the code. But as more senior as we grow, we also need to understand how our users using our software. We are actually the glue between the code and the users. So become product engineers, not just engineers, but also product engineers. Care about the product. Super important. If you think about what you can do as a product engineer, just like if you have written your the first version of a feature, just like do hallway tests. Just go out and ask your coworkers. They know the problems of your users too, so they can give you immediately feedback and before your product manager goes and shows it to users. Or put your developers on support so they understand better what bugs the customer. Actually, companies are running programs where they send developers on support a week, a year, right, or more, right? So 1 week a year they spend on support. And when they come back, and I've seen that, they are totally pumped and say, wow, our users have this particular problem and we can solve that very, very easily, a one-day work, and it's solved, right? So they just like try to put your developers closer to your users. Become data detectives. It's not just like the performance of the software is important, yes, how many threads are running, blah, 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 but how many memory is using, blah, blah, blah. But it's also super important, like where are your users? Where do they spend the most time? How do they use your software? You are just like, you are at the core of it, and you can actually tell your product manager, like, okay, this is what we should work on. Try to be the glue between your code and your product managers. Become product engineers, and that makes you actually super, super effective. All right, I've been talking now for a long time here, more than 45 minutes. I talked about like writing code as a team, like have formatting standards, don't be too clever, write simple code. So everyone in the team understands what you're doing. Constantly learn, invest time in learning. We're not standing still. Software development is evolving. We're in a young industry and we're constantly evolving. Carve out time for experimentation. Try to experiment. Try to come up. Try new things out. Right? Try new technologies. Try new languages. Try out your innovative ideas. Use more time on that. And also, and I think this is the most important thing, work on what really matters for your customers. This is how you move your software forward. This is how you can get a competitive advantage over your competitors. Now, all these things is like, oh, this is a wiggly line, and I told you it's not a complete picture of everything. But if you think more about the outcome instead of the output, that's important. I don't say that being efficient is a bad thing. I mean, it's super important to be efficient too, right? So we should spend time on automating stuff. Maybe learn the command line so you can be faster in typing things than using a mouse, or learn your IDEs more, learn the keyboard shortcut of your IDEs so you're faster, or carve out time for deep work so you are in the zone for a longer time and don't be interrupted by meetings all the time. So this makes you more efficient, right? But efficiency helps you to get more stuff done, where on the other side, effectiveness helps you to get the right stuff done. Or with other words, you work on output if you put your more into the efficiency on the efficiency side, where you work more on outcome on the effectiveness side. So think outcome first, be effective, and then get shit done. Thank you very much. Have a great Devoxx Poland.